Well, this is complete now as regards the wiring. I've still got to put all the modules inside the box, but currently now everything seems to be working. We can control all the axes, no problem at all. That's all working. If I type do a control to turn the spindle on at 1000 RPM, M3 1000, so that's M3S 1000. Now off it goes. We can do that in both clockwise and anti-clockwise, so if we do an M4, don't even have to stop the motor, it will delay and then respin the opposite way. Well, we've got all the axes running. We've got X, Y and Z, and we've got the motor spinning in both forwards and anti-clockwise directions. This was achievable by utilising the output of 1 and 2 on the control board. I did show in a previous video how we set that up, and what we're effectively doing was switching on relays on this board, which you could probably get away with 2 for M3 and M4, which is forward and anti-clockwise, or clockwise, anti-clockwise, however you want to say it. It's a very simple board to power up. I mean, you've got your 12 volt input, and then your output feeds from the main control board, the Mach3 control board, into the input of this. And then you've just got to select how you want to drive the relay, high or low, with the control signal. I've set it to low. The output of these two relays is your M3 command and your M4 for clockwise and anti-clockwise. These are simply switching on the original K2 and K3 relays on the original control board. Just wanted to keep everything isolated and away from each other. The next thing we needed was a 5 volt regulator. Now this is 12 volt input from your DC power supply and your 5 volt output. The next board we needed was this little board. It's a very nice board, it does the job perfectly. Effectively what it will do, it will take a PWM signal input of 5 volts, which is we set with this link, and it will give you from that reference a 0 to 10 volt output. Works really well. So to wire it up, what we've effectively done, I'll just zoom in a little bit, sorry, all the output from the voltage regulator we've taken into the pin marked 10 volt on the breakout board. So we've got effectively 5 volt going in on that pin. The AVI and the ACM pins are going to the PWM input of this control board. The rest of the control board is made up of a 12 volt input. I think you can put more than 12 on it, but 12 to 30 volts I think it says. I've got 12 volts on it, but the 12 volt isn't referenced to the DC power supply. Then you've got 2 grounds, which again are not referenced to the DC power supply, and then your 0 to 10 output. And what I've done, I've powered this side of the board because it's up to isolated by this part from the original control board. I've taken a 12 volt feed off it and powered this board, so it's totally isolated to anything else on here. It's actually powered all but from the SSD control board, so the ground reference is to that part of the board. All sounds a bit confusing, but I will do a drawing and I'll show you what I've done. The only other thing I did was the on this control switch here, which obviously if it was connected and the door was opened, it would stop the motor from spinning. I've basically at the moment, that's relay K1, I've just simply at the moment pulled that to ground with a link wire there, so effectively it's enabled, but that would effectively be controlled by the door control switch. I'll now show you what I've done around the back. On this main control board, I haven't used the original circuit. Just wouldn't give me the output I needed. It would only give me 0.8 of volt output, regardless of what PWM signal I was putting on it. I can only get the motor to spin up to about 300 RPM. What I have kept is the K1 relay, K2 and K3, which is your clockwise and your anti-clockwise direction, and that is the motor enable relay. What I have to maintain isolation for this board from any reference to the other board, the only reference he's got is the PWM AVI output on the breakout board and a ground reference to drive this opto isolator on here. That's the only reference to ground on this board. The ground for this side of the board is taken from the SSD driver. So I've had to pinch from the opposite side of this DC-DC converter, which isolates from the original 12 volt input to this board, which drives the relays, 12 volt feed into this, so this is being driven from 12 volts. Now that gives me complete isolation, so it's effectively just replacing that part of the circuit there. It wasn't needed. And then obviously because it's not needed, I've had to remove some of the pins, which was the 0 to 10 volt reference, which now comes from this board and then directly into the SSD driver. I will put a full circuit diagram of this to make it more clear, with better photos, but I hope that helps, because everything seems to be working now. I've got a lot of work to do to get it all inside and tidy all the wiring up. Maybe use a few screen cables here and there just to cut down any noise. The settings for the software I will show you what I've set at the moment. They probably will change, but this is currently where I've got to, and I'll show you each of the settings that I've got for each of the software. And if you look at my previous videos, you can see how I've wired everything. Ignore the settings. This is the one to use for all the settings, because I did find a conflict on the Spindle drive where I was turning on M7 relay permanently, and that was just because I'd set a pin to say to do that. So use this video for all the reference from the Mach3 software, and hopefully you can get to this point, and from there on it's up to you what you do from there on.